All right, everyone. Today we're going to pull back the curtain on the invisible engines that run our entire world. I'm talking about the unsung heroes silently directing the flow of electricity and everything from our massive power grids all the way down to the smartphone in your hand. Let's get into it. So, have you ever really stopped to think about this? How is it possible that the same fundamental technology can wrangle a megawatt of power in an EV? That's enough to power hundreds of homes, by the way, and yet also be crammed into a tiny, efficient charger that you can toss in your backpack? These two problems feel like they're worlds apart, but the solution comes from the same family of components. And here's the key. There's no single magic component that does it all. The reality is much cooler. As engineers, we have a specialized toolbox filled with different kinds of high-power switches. Each one is a tool designed for a very specific job. The real skill is knowing exactly which tool to grab for which problem. So here's our game plan. First, we're going to open up that toolbox and meet the main families of devices. Then, we'll dive into the single most important concept in this field, the epic battle between power and speed. After that, we'll connect it all to the real world, and finally, we'll take a quick peek at what the future holds for all this tech.
Okay, let's get right to it. Time to pop the lid on this toolbox and get to know the key players. You gotta know what your tools are before you can start building things, right? So at the highest level, pretty much everything falls into one of these three big families. You have diodes, which are basically simple one-way streets for current. Then you've got thyristors. These are our heavy-duty workhorses. And finally, transistors, which give us the most precise, sophisticated control. Now, for today, we're going to focus mostly on those last two, because they're the heart and soul of almost every modern power system.
Let's start with the transistors. The two you're going to run into constantly are the MOSFET and the IGBT. The important thing to notice here is the terminal labeled G. That stands for gate. You can think of the gate as the control knob. It's how we tell the switch when to turn on and when to turn off. These guys are the nimble brains behind so many of today's high-tech gadgets.
And now for the other side of the spectrum, the thyristor family. If transistors are the brains, these guys are the brawn. These are the heavy lifters of the power world. The classic thyristor, also known as an SCR, and its cousins like the GTO, well, they're designed for one thing: handling absolutely immense amounts of voltage and current, way beyond what a transistor could ever hope to manage.
So, this brings us to the million-dollar question for any power electronics engineer. We've got this awesome toolbox, right? It's filled with these different components. Some are fast and smart, others are incredibly strong. How on earth do you decide which one to use? Well, the answer lies in a really simple, fundamental trade-off. And this brings us to what I like to call the power versus speed arena. This is the core concept for everything we're talking about today. Every single device fits somewhere in this arena, and understanding where it fits is the absolute key to good engineering design. So, what exactly is this trade-off? It's pretty straightforward. On one side, you have pure power handling capability. That's brute strength. How many volts and amps can you muscle around? On the other side, you have switching speed. How ridiculously fast can you flick that switch on and off? And here's the catch. With silicon devices, you can't have both. You have to pick one. It's a classic choice between being a power lifter or being a sprinter. To make this choice easier, we engineers like to visualize it. We map out where each device lives on this spectrum. So in the next couple of slides, we're going to see where our major players land, and you'll get a really clear picture of their strengths and weaknesses in this power speed arena. First up in this corner, the undisputed heavyweight champion, the SCR, our thyristor. Just look at those numbers. We're talking 12,000 volts and 1,500 amps. I mean, that is just a staggering amount of power. This device is an absolute monster, built for pure brute force. But what's the trade-off? You guessed it, it's slow. Now, let's swing to the complete opposite end of the spectrum. Meet the power MOSFET. Its ratings are, well, they're much more modest. 1,000 volts, 100 amps. It's no slouch, but it's not in the same league as the SCR. But its superpower isn't strength, it's speed. This little guy can switch on and off millions of times a second. That's a speed the big SCR can't even comprehend. So, you have the strongman and the sprinter. Is there anything in between? Absolutely. Meet the IGBT. This is our versatile all-arounder. It strikes a fantastic balance. It can't handle the insane power of an SCR, and it's not quite as fast as a MOSFET, but it's really, really good at both. It can handle significant power, 6,500 volts, 600 amps, while still switching at pretty high speeds. And this incredible versatility is why you find IGBTs just about everywhere. Okay, awesome. We've met the device families, we get the whole power versus speed trade-off. So now let's do the fun part. Let's connect this all to the real world and see where these different tools are actually being used. Right, in this section, we're gonna play matchmaker. We'll match the right device to the right application. And you'll see how the demands of the system completely dictate which component you have to choose. Let's start at the top, with the really big stuff. Think about massive, grid-scale applications like high-voltage DC transmission lines or giant industrial steel mills. Here, you're trying to control megawatts of power. Speed isn't the main concern, but the ability to handle that power is everything. So who do you call? The heavyweights. This is the natural home for the thyristor family. Frankly, they're the only things that can handle that kind of raw power. Okay, now let's move into the middle ground. Things like the motor in an electric car, or an industrial robot arm, or even a modern welding machine. These applications need to handle a good chunk of power, but they also need fast switching to control things precisely. What's the perfect tool for that job? You got it. It's the sweet spot for our all-rounder, the IGBT. And finally, let's go all the way back to that laptop charger. Why is it so small? The secret is frequency, blazing fast speed. The key component inside is our high-speed specialist, the MOSFET. By switching at incredibly high frequencies, engineers can use much, much smaller components, like transformers and capacitors. That speed is exactly why modern electronics are so compact and efficient. So, look, if you only take one thing away from all this, let it be this. The art of choosing a power device isn't some black magic. It's all about one thing: understanding where that device lives in the power speed arena and matching its superpower to the specific needs of your application. That's the whole game. Now, everything we've talked about so far, it's all been based on good old silicon. But this field is moving fast, and new materials are starting to push way beyond the old limits. So let's take a quick look at what's coming next. For the last 50 years or so, silicon has been the undisputed king of semiconductors. It's cheap, it's everywhere, and we know how to make amazing things with it. But it has fundamental physical limits. It's starting to hit a wall, especially when it comes to that power-speed trade-off we've been talking so much about. And that's where the new players come in. Enter silicon carbide, or SiC. What's so special about it? Well, it basically lets you break the rules. Remember how I said you had to choose between power and speed? SiC devices let you have both. They can switch faster, handle higher voltages, and run hotter than silicon, all while being more efficient. It's a true game changer. And this leaves us with a really fascinating question for the future. As these new silicon carbide devices, which can do the job of both a high-power device and a high-speed device, get cheaper and more common, which of the classic tools in our silicon toolbox do you think is going to become obsolete first? The big thyristor? The versatile IGBT? The speedy MOSFET? Something for you to think about. That's all for now.